with Camilla, and Camilla's here to help us explore the angles of polygons. In this video, we will learn to apply the Polygon Angle Sum Theorem. We will also learn how to apply the Exterior Angle Theorem for polygons. About that little triangle right there. To start us off, what's a polygon that most people over the age of 16 take a moment to stop and look at least once every day? Now here's a polygon. It's a polygon that resembles a very famous building in Washington, D.C. And I bet you already know that this is a five-sided polygon, 1, 2, 3, 4, 5, which is a pentagon. When we're talking about the interior angles and even exterior angles of polygons, we're working with convex polygons. So we can leave stars out of this equation, but we're going to find the sum of interior angles of a convex pentagon. Well, that is a very simple formula. Here it is. It's a very simple formula, and it works for any convex polygon. It doesn't have to be a regular polygon, but any pentagon. The sum of the interior angles of a pentagon is n minus 2 times 180. N is the number of sides. So let's do 5 minus 2 times 180 degrees. Now I know from experience, because every convex pentagon has this magic formula, that 3 times 180 is 540 degrees. So look at this. We have a regular convex pentagon with all angles and sides are congruent, and we said that the sum of the interior angles is 540 degrees. Well, the angle sum theorem for polygons states that as long as it's a convex polygon, this formula works. That's the n minus 2 times 180. And we can say that the sum of the interior angles for this polygon as well equals 540 degrees. The sum of the interior angles is the same for both. However, we can say what is the measure of each angle inside a regular convex pentagon. Because they are all equal and they add up to 540, can't we find the measure of each one? And so look at this. For a regular convex pentagon, the sum of the measures is 540, and each angle, all we have to do is divide by the number of sides, which is also the number of interior angles, and that is 540 divided by 5, and each angle measures 108 degrees, 108, 108, all the way around, and that's a very useful number that won't change no matter how large the regular pentagon is. Now let's come on down here. If each angle is different and the sum of the angles is 540, we know that won't change. Can we find each angle just by what we're given here? We cannot. So we know that the sum of the interior angles of any convex pentagon is 540 degrees. But when it's an irregular, as this one is, we have to be given terms that represent what is each angle in terms of x, or a variable. So now we can get each angle, and you can see they're all different. A couple of them are the same measure, but this is not drawn to scale. So we're just going to use a mathematical minds to figure out how much do all of these need to add up to. Here comes a little bit of algebra fun. All we have to do is plug that x into every angle and find out what each angle is. This is a fun one because we have a 1, 2, 3, 4, four-sided polygon. That's a quadrilateral. Now, a quadrilateral, we could find out what the sum of the interior angles of a quadrilateral is, n minus 2 times 180. But we're not looking for that now. We're looking for the sum of the exterior angles, which we know, what is the sum of the exterior angles of any convex polygon? 360 degrees. Well, if we know that the sum of the exterior angles is 360, and there's 1 at every vertex, which means there's 4, we are going to add each of those terms, and they should all add up to, got it, 360. So let's do it. Ready? I'm going to start and just go clockwise. Equals 360 degrees. Good enough so far. Add 14. 11x equals 374. Do I know that off the top of my head? I'm going to use a calculator. And can you believe it? X is a whole number. 34. Now, if I asked for x, you would be done. If I asked you to plug x in and get every exterior angle, you could do that. And if I asked you what do all of those exterior angles add up to? 360 degrees. Always for convex polygons. Magic number, 360. And thanks for helping, Misha. And thanks for watching.